We are given the curve with equation y equals 2 plus e to the negative 2x. The curve crosses the y-axis at the point A, and the point B on the curve has x coordinate 1. The shaded region is bounded by the curve and the line segment AB. We need to find the exact area of the shaded region. The shaded region is actually the difference between the area of the trapezium bounded by OAB and this point here. And then we have the area under the curve from 0 to 1. So that gives us the area under the curve. What we could do is the area of the shaded region, that would be the area of the trapezium minus the area under the curve. So what we need to do is to find the area of the trapezium. Now, in order to find the area of the trapezium, we need to know the length of OA and the height of B here. So we know that this side is 1 already, the width is 1. To find the height of point A, that is just the y coordinates of point A that occurs when x is 0. So when x is 0, the y coordinate or the height of point A is the y coordinate of this curve here. We have y equals 2 plus e to the negative 2 times 0 is e to the 0, and e to the 0 is 1. So that is 3. Then we know that A has coordinates 0 and 3. And we also know that height A here is 3. To find the height of point B, we need to find the y coordinates of B when x is 1. So we let x to be 1, and y is 2 plus e to the negative 2 times 1, which is 2 plus e to the negative 2. Then point B has coordinates 1 and 2 plus e to the negative 2. And we also know that the height of this point B here is 2 plus e to the negative 2. We can find the area of the trapezium. We can redraw the trapezium, and then we have B, we have A, and that is AB. That is A, that is B. This is 3, you have a width of 1, and 2 plus e to the negative 2. We know that the area of the trapezium is given by half of the width, which is 1. And then we have the sum of the two heights, 3 plus 2 plus e to the negative 2. And the area of the trapezium is half of 5 plus e to the negative 2, which is 5 over 2 plus half of e to the negative 2. That is the area of the trapezium. We need to subtract this area from the area under the curve. The area under the curve is the definite integral of this curve, which is 2 plus e to the negative 2x from 0 to 1. Upon integration, we have 2x, then this e here is e to the negative 2x divided by negative 2. And that would be 2x minus 1 over 2 e to the negative 2x evaluated from 0 to 1. So to evaluate this, we replace x with 1 that is 2 minus 1 over 2 e to the negative 2 minus, we replace x with 0, then you have 0 minus 1 over 2 e to the 0. And that is 2 minus 1 over 2 e to the negative 2 plus 1 over 2. E to the 0 is always 1. So the two negatives give us a positive, and that is 5 over 2 minus 1 over 2 e to the negative 2. We need to make use of this to find the area of the shaded region. The area of the shaded region is the area of the trapezoid, which is 5 over 2 plus 1 over 2 e to the negative 2, minus the area under the curve, which is 5 over 2 minus 1 over 2 e to the negative 2. And we have 5 over 2 plus 1 over 2 e to the negative 2 minus 5 over 2. The two negatives is a positive, 1 over 2 e to the negative 2. 5 over 2 is gone, so half of e to the negative 2 plus half of e to the negative 2 is e to the negative 2. That will give us the area of the shaded region, or the exact area. Do not change to decimals.